Okay, so we are going to look at gravity problem B for this question. It reads, a spring-loaded gun shoots a 0.005 kilogram bullet vertically upward from the ground with an initial velocity of 21 meters per second. And there's two parts. Part A says, what's the height of the bullet after 3 seconds? And the second part, is it on the way up or on the way down at 3 seconds? So let's tackle that problem. The first question we have to ask is, what is our object of interest? And in this case, that is the bullet. Then we have to define that initial and final condition. What starts the motion? What ends the motion? When does our stopwatch start? When does our stopwatch end? So I encourage you again, pause the video, do your listings, and then restart to double check your answers. So initial, well, that's when the gun is shot and the bullet leaves the barrel. Final is, well, we're interested in that 3-second mark. So that's at 3 seconds. So our situation after 3 seconds at 3 seconds. Okay, we then want to start asking ourselves those extra questions. Am I in a state of free fall, and am I in a state of regular one-dimensional motion? And as you know, maybe even am I in a state of two-dimensional motion? Well, we're in a state of free fall here, so do keep that in mind as we generate our list of notes. Okay, so we have to identify the world. So here's our gun with the bullet being shot upward, and I have to identify where the origin is. So we will say the origin is at the bullet. Now we go to our list. We are in one-dimensional motion, so we have a single list. X initial, X final, V initial, V final, acceleration, and time. So our initial position, when the bullet leaves the gun, I've set that at the origin, so I can define my initial position as 0. Final position, I don't know. That's a question mark. The initial velocity, how fast is the bullet moving when it leaves the gun? That's given in the problem as 21 meters per second. Again, it's always good to check that direction. Should it be positive? Well, it says it shoots the gun up, or the bullet up, so it should be positive. So this is, in fact, positive value. V final, is that final after 3 seconds? I don't really know. Oops, that's 3 seconds. So I don't know, that's a question mark. And acceleration, it's not given in the problem, but we've identified this as a case of free fall. And so if I'm only under the influence of gravity, my acceleration is 9.8. Our time, well, we're interested in the time after 3 seconds. So that is defined for us for the problem of 3 seconds. Okay, part A was, how high does the bullet go after 3 seconds? Well, if 0 is our initial position, we've defined it as the origin, our final position is going to be how high. And we know that final position is one of those powerful equations that we have, and we can use it to identify that final position. So X final is our question mark. That's what we want to know. X initial is given to us as 0. V initial is 21 times the time of 3 seconds plus 1/2 negative 9.8. Don't forget that whether it's up, down, or sideways, gravity is always, acceleration due to gravity is always negative in free fall. And our time of 3 seconds squared. And common mistake is to square the whole thing. Remember, it's just the time that's squared. So if we look at that, we end up with an X final equal to 18.9 meters. So X final does, in this case, define how high the bullet is after 3 seconds. That's part A. And we might expect the bullet to be traveling above the origin at that point. Not always intuitive, but it's not unreasonable. All right. The next part of the question says, is it traveling up or on its way back down? Well, that one's a little tougher. We have to think about, what does that mean? How would we know if an object is on its way up or on its way down? Well, that's going to tell us something about the direction of motion. And that, of course, is velocity. So our final velocity is what's going to give us that information. What equation do we use? Well, that final velocity one. So final velocity equals initial velocity plus acceleration times time. So final velocity is what we're interested in. That remains its variable. Initial velocity is given as 21, plus our acceleration of negative 9.8 times our time of 3 seconds. And when we do that, we find that our final velocity is negative 8.4 meters per second. So that negative is what gives us the information. Negative means the object is traveling down. So, same process as we've always used, remembering that if I'm in free fall, my acceleration is negative 9.8. And the second thing is thinking about what that second question is asking. Traveling up, traveling down, that's information about direction of motion. Direction of motion information comes from that velocity information. Negative telling us it's down. Nice job.